Okay, so in case you missed the class this Friday, I brought to class a baseball bat. This happens to be a Torpedo baseball bat. And I don't know if you're familiar with a Torpedo baseball bat, but it's one that's had some controversy in baseball lately. It's a little bit, it changed its design a little bit to increase the size of the sweet spot. Now, the sweet spot is a place on the bat where you get the most distance when you hit the ball. And it's not at the end, but it's been out towards the end before, and they've moved it in a little bit because of and with that being in, that makes swinging the bat. You can get better bat speed. You can be quicker reacting to the fast speed pitches that are happening these days. So they've moved the sweet spot in by changing the distribution of the mass. And so what we did in class was just try to figure out the volume of this. Now, if we had an equation for the profile of this bat, we could integrate that and do with that equation spun around the x-axis and come up with the volume. But since we don't have the equation for that, and the equation is, I'll show you something here on Monday that shows how complicated that is. But if you think of the baseball bat, you can think of it as a series of cones, but not really cones, just parts of a cone. So if I had a cone and took just a chunk of the cone, this piece here that's going around, it's kind of a wedge part of the cone, that's called a frustum. Okay, maybe it's frustum. Oh, I'll have to look that up. Maybe there's not an R there. Anyway, it's something like that. I wanted to find out what the volume, the equation, the formula for that is, and I could have looked it up, and I did after I created the formula using calculus, and that's what we did in class, is come up with the formula for either a frustum or a fustrum, the volume of this. So, there's a short radius here and a larger radius here. And if it's a perfect cone, these are straight lines. And if I put a coordinate system here, this line would be y equal mx plus b, but since I put the origin there, it'd be plus 0. So the slope of this line is just y equals mx. And if that's the case, the coordinates of this point are, well, this is the y direction, so it's little r. But what's the x direction? Well, to find x from this equation, I'd take y, which is r, little r, divided by m. Little r divided by m is what x would be. Little r divided by m. And this point would be big R divided by m, r. So, to find the volume of this, I'm going to do a disk slice. I'm going to slice it here, and imagine that spun around. So the thickness of the disk is dx, and I'm doing the integral from, my x is going to go from little r over m to big R over m, between the two x values, of, that's y to a point on the curve, y squared dx, and it's pi, y squared dx. But y squared is mx, y is mx, so I'm going to change this right away to mx quantity squared, so it's m squared x squared. M's the slope, so I can pull that out. So I get pi m squared. Integral of x squared is x to the third over 3 d, and so that's the integral, and so I have to evaluate that between little r over m and big R over m. And if I do that, I get pi m squared times big R over m cubed. See, there's a 3, a 3 in the denominator here. I'm going to pull that out here right away. So it's going to be r cubed over m cubed minus little r cubed over m cubed. And since there's an m cubed in both of them, I could pull that out, and it would cancel 2 of them. Cubed, should be a cube there. So I get pi m squared would cancel 2 of them, and so I get over 3m of r cubed minus little r cubed. And I can use this formula, but what is m? Well, m is the slope, and the slope of this line is big R minus little r over, that's the change in y, over the change in x. Well, the change in x is this distance, which I'm going to call the height of the frustum. So this is going to be pi over 3, the slope, which is big R minus little r, divided by the change in x, which is h. So if I invert and multiply, the h would end up here, and then I'd have it times r cubed minus little r cubed. And if you remember your algebra from a while back, a cube minus a cube factors. Let's just look at that. It seems like it might have a factor like r minus r, and it does. And what's left is that squared, and a minus r, little r squared is plus little r squared. And this times this, which is minus the 2 r's multiplied, but if you change the sign, go plus big R times little r, that's how that factors. To prove to you that, I'm going to take this times this times that, this times that, minus little r times that, minus r times that, minus little r times that, and minus little r times that. And these cancel, and I get r to the third minus little r to the third. So this is what this factors to, and so this would cancel that. And so if you look up a formula for the volume of a frustum, I think it's frustum, over 3h r squared plus r plus little r squared. That's dividing this into this, which creates this. Could have got it by a long division also. So there's the formula for the volume of a frustum. So then in class, you can see that this bat, I've taken and marked off some places on it. I actually did several distances here, but here's 1 inch, here's 2 inches, and 3 inches, and 4 inches, and so on up the bat. And we measured the diameter here, divided those by 2, and used them in this formula to figure out the volume of the frustum here, and this frustum, and this frustum, and this one, all the way up the bat. Some of them we saw that they were pretty straight, and we skipped and did several spots. But if you do that, you'll get the volume of the bat. Except for this part gets a little tricky, and I didn't have those in there, but we're going to talk more about that in next class. And in the end of the bat, let's see if I can get shown around here, they've got a hole in it. And I was curious as to the size of the hole. Maybe it would fit something. Pulled out a ping pong ball, and it fits in there exactly. Half the ping pong ball. Whatever they use to make that hole, it's the size of a ping pong ball. Okay? So we're going to talk more about that on Monday. All right.